steady speed of 50 meters per second at an altitude of 300 meters. The pilot releases a parcel when directly above a large X on level ground. Draw a diagram of this situation. So again, just a very simple plane will do. The height above the ground is 300 meters. There is an X on the ground here. The parcel is going to follow a parabolic path and hit the ground over here, some distance away from the X. The plane is traveling at a speed of 50 meters per second horizontally. And so the parcel is traveling with initial horizontal speed of 50 meters per second as well. V, calculate the time of flight of the parcel. So that's just determined by what happens in the vertical direction. So in the vertical direction, we want a displacement of minus 300 meters. The acceleration is minus 9.81 meters per second squared. And the initial speed is 0. So we're going to use the equation S is equal to ut plus half at squared. U is equal to 0, so we can get rid of this term. Same rearrangement as last time. T is the square root of 2s over a. In this particular case, that's the square root of 2 times minus 300 over minus 9.81. Gives us a value of 7.8 seconds. Again, just checking the significant figures. 2 looks reasonable. It could be 1. We could argue it was 1. We can't tell with these numbers, can we? Are they 1, 2, or possibly even 3 significant figures? But let's go with 2. 7.8 seconds. If you've written 8, that's fine. The speed of impact of the parcel. Use Pythagoras' theorem to add the 2 velocities. So by the time the parcel reaches the ground here, it will have a horizontal velocity, which we know will still be 50 meters per second, but it will also have a vertical velocity. The vertical velocity we can get from the vertical information that we've already used. We want to solve our equations to find V in the vertical direction first, and then we'll put the 2 together using Pythagoras. So in the vertical direction, the things that we know are S is minus 300, A is minus 9.81, and U is equal to 0. And the thing that we want to find is V. We could use the T from last time, but it's probably better to go back to the original information that we were given. So we're going to use V squared is equal to U squared plus 2AS. This term again is 0. So V is the square root of 2AS. V then is the square root of 2 times 9.81, which is negative, and times 300, which is negative. Gives a value of 77 meters per second. It's not quite the end of the question, because we then need to find the total speed. Let's have some more room. The total speed when we put these 2 vectors together. So just to draw a short diagram, we've got a vertical speed of 77 meters per second and a horizontal speed that I've drawn that looks bigger, but it's smaller. It's still 50 meters per second. So to find the resultant of the 2, we're going to add them up using Pythagoras. So we want the total velocity. So the I'm going to name it VT. The total velocity is equal to the square root of 77 squared plus 50 squared. which is 92 meters per second. The distance from X to the point of impact. So this follows from part B. In part B, we found the time of flight. So in part D, we're just going to look at the horizontal information. We know the time of flight we calculated was 7.8 seconds. We know the acceleration in the horizontal direction is 0 meters per second squared, and the initial speed was 50 meters per second. So again, we're really using our non-accelerated motion equation because the acceleration is 0, so just distance is equal to speed times time. That is 50 times 7.8, which is 390 meters.